standalone variable speed drive, or VSD, often needs a disconnect within site for several key reasons, primarily related to safety, maintenance, and code compliance. Firstly, consider safety. In the event of an emergency, such as a fire or electrical fault in the immediate vicinity of the VSD, it is crucial to be able to quickly disconnect the VSD from its power source. A disconnect switch located within site allows for immediate intervention, minimizing potential hazards to personnel and equipment. Time is of the essence in such situations, and having to locate a remote disconnect could significantly delay the response. Secondly, think about maintenance. When performing maintenance, repairs, or inspections on the VSD, it is essential to isolate the device from the power source to ensure the safety of the technicians involved. A disconnect switch within site provides a readily accessible and reliable means of de-energizing the VSD, preventing accidental energization during work. This local disconnect ensures that the VSD is completely isolated, reducing the risk of electrical shock or other injuries. Thirdly, code compliance is a significant factor. Many jurisdictions mandate the presence of a disconnect switch within site of a VSD to adhere to electrical safety standards and regulations. These codes are in place to protect workers and prevent accidents by ensuring a safe working environment. The specific requirements may vary depending on the local electrical code, but the underlying principle remains the same: a local disconnect is required for safety. While it is sometimes permissible to have a remote disconnect switch for the VSD, this is not always practical or safe. In many industrial settings, the VSD may be located some distance from the main electrical panel or motor control center, making a remote disconnect less accessible and more time-consuming to operate. Furthermore, relying on a remote disconnect may introduce additional steps and communication requirements to ensure that the VSD is properly de-energized before work begins. Having a disconnect switch within site offers a more straightforward and reliable method of isolating the VSD. Consider specific scenarios where a local disconnect is particularly beneficial. Firstly, imagine a fire breaks out in the area where the VSD is located. A disconnect switch within site allows anyone in the vicinity to quickly cut power to the VSD, reducing the risk of the fire spreading or causing further damage. Secondly, consider an electrical fault within the VSD itself. A local disconnect enables immediate isolation of the faulty device, preventing potential harm to personnel and minimizing damage to other equipment. Thirdly, when maintenance is required and the VSD, a disconnect switch within site ensures that the device can be safely de-energized before any work begins. This eliminates the risk of accidental energization during maintenance, protecting technicians from electrical hazards. In summary, having a disconnect switch within site of a standalone VSD offers significant advantages in terms of safety, maintenance, and code compliance. It enables quick isolation of the VSD in emergency situations, simplifies maintenance procedures, and ensures adherence to electrical safety standards. While remote disconnects may be permissible in some cases, a local disconnect provides a more reliable and convenient means of de-energizing the VSD, promoting a safer working environment. Therefore, the requirement for a disconnect within site is rooted in practical safety considerations and regulatory compliance, making it an essential feature of many VSD installations.